So we're going to be discussing wave behaviors. These are what we went over last week and this beginning of this week. The first wave behavior is reflection. A reflection is when a wave strikes an object or surface and bounces off. There's two different types of surfaces that allow a reflection to occur. It could be a smooth surface or a rough surface. If you see in the picture, a smooth surface will reflect back in one direction. This would be an example of a mirror where you can see yourself clearly, a still pond or lake. Echo. So when you're using a sound and you have some sort of echo come out, that is going to be a smooth sound. Some surfaces that are rough and reflect, they're going to reflect in many directions. So your image, when it's reflected back, is not going to be clear or sharp. So you're not going to see the exact image that you're supposed to see. You'll kind of see it where it's a little bit blurry. That would be an example of a rough surface. Now, refraction is the second wave behavior, and this is the bending of a wave as it moves from one medium onto another. What happens with mediums, remember, that has to deal with gas, liquid, solids. Those are different types of mediums. And remember that light travels faster in gas than liquid. Something to also know is that the speed of the waves changes as it passes from air to water. So when you go from air to a liquid, it's going to bend towards the normal. Whereas if you go from liquid to air, it bends away from the normal. So that's why you kind of see that bending happening. And when you look from the outside looking in, that's why the pencil in the cup that's in water looks like it's kind of shifted. Same with a fish in a bowl. If you look down, you're not actually seeing directly where the fish is. The rainbow, that's another example of a refraction. And something to know about the rainbow is that when you look at colors, colors of light separate to wavelengths when light hits raindrops. So you'll notice that different colors are refracted in different amounts because each color has different wavelengths. If you know Roy G. Biv, that's the order from greatest to least when it comes to wavelengths, so longest to shortest. So red for light is going to always be your longest wavelength, and violet is going to be your shortest wavelength. Now, the third type of wave behavior is diffraction. That's the bending of waves around a barrier or through a barrier. Sound actually bends more than light because sound waves have larger wavelengths. Some examples of diffraction is hearing sound around a corner, a break in a water in the harbor, so something that's controlling the water to go around. Same with like a rock in a river or a brook.